Hi, welcome to another video. In this particular video, we're going to talk about equations of motion. Motion is one of the basic concepts in physics. Most topics under classical mechanics, they have a relationship with motion, and it's like one of the first concepts that you will learn when introduced to the world of physics and how the whole thing works. So motion literally is talking about how objects move, and equations of motion for a body traveling along a straight line with uniform acceleration. Acceleration is talking about how much, by what amount is the speed increasing. We've got three equations of motion. We have the first equation of motion, we have the second equation of motion, and we have the third equation of motion. So first things first, velocity equals displacement, or what we call distance over time. So now we're dealing with the first equation of motion. Let's see how we can derive the first equation of motion. And right after that, we know that acceleration, that's what you have as A, equals velocity over time. Now the velocity we have here is written as the change in velocity over the change in time. And the change in velocity, as the case may be, is the final velocity minus the initial velocity. So we can replace change in v with v minus u. So rewriting this, we can have v minus u divided by the time interval. If you have to make v the subject, let's just do v minus u equals at, and then you have v equals u plus at. So what you have right here is the first equation of motion. Now the second equation of motion can also be derived if we consider that a body moving with uniform or constant acceleration must have an initial velocity u before attaining a final velocity v, and our starting point here will be the average velocity. An average velocity u plus at divided by 2. Let's just have average velocity as v average. Yeah. Okay, so simplifying this, v average will be u plus u, that's 2u plus at over 2. Okay, now here you have a fraction, and how about we separate it? Okay, and this becomes 2u plus at divided by 2 divided by 2. It's the same thing. We can actually cross out these guys, right? And then we'll have this equal to u plus. Now here, there's an imaginary one here. Since it's one, it's hidden, so that one will surface here as half a t. All right, and then we have v here. Now this v, we'll just turn it into we'll just substitute. Now velocity is displacement or distance over time. So how about we just swap these guys, right? Okay, so s over t, that's what we're doing. And then just one more thing you have to do here. What do? You cross multiply. Yeah, that's it. You cross multiply. And once you cross multiply here, you will have S equals U plus half AT into T. And you expand this, you will have UT plus half AT squared. And right there and then, you've got the second equation of motion. Great. One more to go. Now, let's talk about the third equation of motion. And this deriving the third equation of motion is a little bit tricky, and it also involves a combination of both equation 1 and equation 2. So what is equation 1? Earlier we got that equation 1 is u plus at. In its original form, we usually have it as u equals plus or minus at. Plus, if it's accelerating, then we'll have minus if it's decelerating. But we'll talk about that in another video. But for now, let's just stick to the positive. And then the second equation of motion is S equals u times time. That's initial velocity times time plus half at squared. So we're still going to revisit equation 1 and equation 2 right about now. So for equation 1, we have u plus at. Now what if we square both sides? You square both sides, you'd end up with v squared equals u, let's do it this way, u plus at squared. And this is u plus at, u plus at, and we just open the bracket. Now, do not make the mistake of coming here and saying, oh, this is u squared and this is at squared. No, wrong. Don't do that. Okay, so this is v squared equals u times u, as u squared, plus u times at, that's uat, plus at times u. Can you see? That's uat, and then you have at times at. Sorry, it's a little bit rough. That's a squared t squared. A times a squared. T times t squared. So what do we have? That's v squared. That's v squared equals u squared plus uat plus uat. That's 2uat plus a squared t squared. Now, how about you factor out 2a? Now, factoring out 2a is not from the whole equation. No, not from the whole equation. We're just doing that for the last two equations, these guys. Okay, so let's say we want to factor out 2a here. We'll have our guy here, and then that's 2at plus a squared t squared. So the fold is ready, and let's just make the cut. So u squared plus this is 2a, and right here you've got 2uat divided by 2a, and a squared t squared divided by 2a, and so we're just doing lots of writing here. So 2a, let's do the math here. We just cross this, you cross this, and just cross one of this, you see. And let's just write out what we have left here. That's ut plus, we've got half. Remember, there's a hidden one here, even though you can see it. Every expression that has no number has at least one. Okay, so you can bring it out if you need it for your derivation and your workings. Okay, so half at squared, and remember that this looks like this guy. Let me just bring it down. like the second equation of motion. Exactly the same. So let's just substitute ut plus half at squared, what we have in the bracket, for s. That's just the final piece of the equation, and that would give us v squared equals u squared plus 2a. So all this would be s, 2as, and here is the third equation of motion. Third equation. So can you remember the three equations? If you can, just drop them down in the comment section, and you can also do well to go over the derivation yourself. The more you practice, the better you get. And for the derivation, even though you forget the equations, you can quickly work them out even in an exam situation. So that will be all for this video. Bye, and I'll see you